Hi guys, in this video we're going to work on a couple problems with twists. We definitely need to worry about extraneous solutions in these, trust me. Okay, so what we're going to do is we need to solve for this problem, and the problem that we face that we haven't faced before is that this has a log and that does not. So how do we solve this? Let me show you two different approaches. First of all, this says 2 raised to what power gives me x minus 4. That's what we've been talking about all along, right? What does logarithm mean? 2 raised to what power gives me x minus 4? 2 to the third power. So if I just simply take this and I swing the 2 over here and I rewrite it as an exponential equation, the right-hand side becomes 2 cubed. And the left-hand side, after I swing this over, is just left with the x minus 4. There's the exponential form of that equation. Now I can say, well, 2 cubed is just 8. So x minus 4 is equal to 8. And I add the 4 to both sides. X must be 12. So what looks like a difficult problem ends up being pretty simple, right? I would go through and I check and I say, okay, what is 12 minus 4? 12 minus 4 is 8. That's a positive number. We're going to be okay there, okay? Because we need to check the domain, right? The other approach to doing this, and this is something that might help us with more complicated problems later on, is this. If I see log base 2, I'm going to do what's called exponentiating the problem, which basically means I'm just going to rewrite it as if these two things are equal, then 2 to this power equals 2 to this power. They have to be equal. So I can write them as both as the exponent. So I'll just move my equal sign down a little bit, right? I can rewrite it like this. Why did I choose 2? Because it's a log base 2. If that would have been a 3, I'm going to say 3 to this side equals 3 to this side. If that was a 10, I'm going to say 10 to this side equals 10 to this side. And what that does, though, is that the 2 and the log base 2 cancel each other out because they're opposites. Kind of like E and ln are opposites. 2 and log base 2 are opposites. So the right-hand side gives me just the x minus 4, and the right-hand side is 2 cubed, which is just 8. Oh, looky there, same answer, right? So there's two approaches to solving the problem. There's the first twist that we might see. In other words, ready? Either rewrite it as a logarithm, if you understand that, or say, because it was base 2, 2 to this side equals 2 to the right side. Last problem, ready? What happens if I get 2 natural logarithms on the left-hand side? Can I just say x plus 2, x minus 2 is 24? And the answer is no. What you have to remember is you have to condense first, okay? The big deal here is that we have to condense first. We must. And so if I see plus, I know that that can be rewritten as a single logarithm, and plus means multiply. So I'm going to be multiplying an x by an x minus 2. Notice that's going to be distributive property, isn't it? That equals the natural log of 24. No condensing to do on the right-hand side. And so if I distribute out the x, that becomes natural log of x squared minus 2x on the left, and a natural log of 24 on the right. And now I have one natural log on both sides. So if the natural log of this equals the natural log of that, well, these two pieces must be equal to each other. X squared minus 2x must be equal to 24. That's a parabola problem, guys. You know how we solve parabola problems? We move everything to one side, x squared minus 2x. Let's subtract the 24 from both sides. And now let's factor. Two numbers that multiply to negative 2, or excuse me, add to negative 2, multiply to negative 24. Negative 6 and positive 4. So this factors out to x minus 6, x plus 4 is equal to 0. If you don't know how to factor, you need to go back and review that. So that means that either x minus 6 is 0 or x plus 4 is 0. My two solutions are 6, because 6 minus 6 is 0, so I'm adding the 6 to both sides, or I'm subtracting the 4 from both sides, so my two solutions are 6 and negative 4. Now let's go back and let's check. If I put a 6 in, I get positive numbers everywhere. That's the natural log of 6. I'm good there. This is 6 minus 2, so that's natural log of 4. So everything is positive. That doesn't have an x in it, so I don't need to check it. Let's go put the negative 4 in. If I put the natural log of negative 4, that's a negative value here. And so what happens is you'd be trying to do this. The natural log of negative 4 plus the natural log of negative 4 minus 2 is negative 6 is equal to the natural log of 24. And the problem is if you both put that on your calculator, it's going to say, wait a second here. I don't know what the natural log of negative 4 is. It doesn't even know how to do that. And so therefore, we have to come down here and we have to cross this out. That is called an extraneous solution. The only solution to this is actually x equals 6. All right, that's a tough problem. That'd be one you'd see at the end of the test, but hopefully it makes sense. It's tough not because of what we have to do up here in the natural logarithm stuff. It's tough because you have to know how to factor, guys. That's chapter 4 stuff. So hopefully that gets you through the homework for today, and we'll have time to practice this in class together another day.